Hi guys, welcome back to my channel. So for this time, we're going to have rational numbers, and our focus will be how are you going to convert fractions to decimals or vice versa. So let's have the first one. Okay, but before we have the examples, let us be guided by the rule first that when you are going to change fractions into decimals or decimal forms, the very important thing to do is to divide the numerator by the denominator, and that's it. You will be ending up with a decimal number that is either terminating or non-terminating. So let's have the first one. We are to convert 24/5 into a decimal. So we just put the equal sign first there, and then as the process says, we are going to divide the numerator by the denominator. So 24 to be divided by 5. So how many 5s are there in 24? We have 4 5s. Therefore, we write 4 there on top, and then 4 times 5 is 20. We subtract the 2, and the difference will be 4. We bring down the 0. So the 4 there becomes 40. With the decimal point on top also. So 40 divided by 5 will give us 8. And 8 times 5 is 40. You'll stop dividing until you get a 0 difference. But if you still have a remainder, then that's the time that it's either you're going to come up with terminating or non-terminating. Okay, so therefore, we stop there because the difference is 0 already. There we have 4.8, or the proper way of reading this is 4 and 8 tenths. Okay, let's move on to the next one. The next one is 2 and 3/8, which is an example of a mixed number. Take note, it is a mixed number. A mixed number is a combination of a whole number 2 and a fraction 3/8. Again, this is a mixed number. We are going to convert this into a decimal number. There's no need for you to convert this into an improper fraction. This will be fine already. So since you have a whole number in that mixed number, you just have to put 2 there and then a decimal point after it. Okay? So all we have to do is to simply convert this 3/8 into a decimal number. So we have to divide 3 by 8. So 3 is smaller than 8, therefore the resulting decimal number for 3/8 is less than 1. So we put a 0 there, and then you put a decimal point beside 3, a decimal point on top also. And we add 0 beside the decimal point, so we have 30 now. 30 divided by 8 is 3. 3 times 8 is 24. So you subtract the 2, you get 6. Bring down another 0. Put 0 here, bring it down. 60 divided by 8 is 7. 7 times 8 is 56. Subtract again, get 4. Add one more 0 there and bring it down. So that we'll have 40. 40 divided by 8. So we get an exact value, a quotient there. So 5 times 8 is 40. So we now have 0.375. So we just add that in the whole number 2, making the answer be 2.375, or the proper way of reading this is 2 and 375 thousandths. Okay, let's move on to the third one. So the third one is 19 thirds. So we all know that whenever the denominator is 3, it reminds us of something, that we will be getting a decimal that's not ending, or what we call non-terminating decimal. So put the equal sign there, and then we divide 19 by 3. Okay, so 19 divided by 3, there are 6 3s in 19. So we have 6 point something there. So 6 times 3 is 18. We subtract the 2, you get 1. And then we put a 0 beside 19, the decimal point. So there's a decimal point there also. Bring down the 0. So 10 divided by 3 is 3. 3 times 3 is 9. Subtracting the 2, you get a difference of 1 again. And you will notice as this process goes on and on, you will be getting 3's there, and it will be endless. Okay, so you have 9 here, and then 1, and then and so on and so forth. So this time we have an example of a non-terminating decimal, wherein a digit in the decimal number, a decimal part rather, is repeating. So we call this we have 6.3 with a bar on top of 3, which means that 3 is not ending, or 3 is repeating. So we have there 19 over 3 is equivalent to 6.33333 ellipses, or 6.3 with a bar on top of 3. Okay? So that's it for fractions to decimals. Let's proceed to the next set of examples. So this time around, it's the reverse of what we did in the first 3 examples. So this time, we are going to convert decimals to fractions. Okay? So first, let's recall the rule. So we have here, if you're going to change or to convert decimals into fractions, first you have to write the decimal number as how it must be read. It must be read correctly. Just like 2.5, it must be read as 2 and 5/10. Okay, you write it as how it must be read correctly. And using the equivalent fraction, we simplify it if possible. So let's take the first one. We're given 0.28. As the rule says, you have to write this as how it is, it should be read correctly. So we have 28 hundredths. 0.28 is read as 28 hundredths correctly. Now, we are going to get the GCF of this two. 28 and 100 can be divided by 4. Now, the question is, Mom, what if I did not get the GCF? Would that be okay? Yes. But the only problem, or the only the consequence of that would be you'll just be dividing a number of times. Unlike when you get the GCF, division will just be done once. Okay? So going back with this, 28 and 100 are both divided by 4. So 28 divided by 4 is 7, which is a prime number. It already gives us a hint that we are about to get the simplest form already. And 100 over 4 is 25. And there you have 7 over 25 as the equivalent fraction of 28 hundredths. So there you have it. Okay? Let's now have the second one. So the second one is 2 and 125 thousandths. So we just write 2 there. Or maybe erasing this, we'll just write, we'll just have it to leave to alone first. We're going to have 125 thousand. So we write it as 125 over 1000. Okay. Now, as you can see there, 125, you can divide 1000 by 125, right? You can divide 1000 by 125. So, with that, we are going to divide both the numerator and the denominator by 125. Okay. So again, if you cannot get the GCF right away, it's okay, but dividing will be done more than once. So 125 divided by 125 is 1. All over 1000 divided by 125 is 8. So there you have, if you're going to put the 2 here, you have 2 and 1/8. But 2 and 1/8 is not a fraction. So this must be changed into an improper fraction. It's a mixed number, take note. So we are going to recall the process of converting this mixed number into a fraction. So we multiply and then add. So doing that, 8 multiplied by 2 is 16. Added to 1, that will give us 17. All over the denominator 8. So there you have 17 over 8. Then you check in your calculator. When you divide 17 by 8, you should be arriving at 2 and 125 thousandths. Okay? So let's clear this screen first. And then let's return these items. Let's proceed to the next one. So the next one is an example of a non-terminating repeating decimal. Okay, so we have 6/10 with a bar on top of 6 to be converted into fractions. Okay, so I'll give you the technique first, and then later I'll be revealing the solution to that using the log method. Okay, So if you are going to convert a non-terminating repeating decimal into a fraction, you just have to turn it into a fraction first, following the format that the numerator will be the digit, the number formed by the digit that's repeating. So in this case, we have 6. Therefore, our numerator will be 6. And then, the denominator will be a number of 9s. The number of 9s depends on the number of digit that repeats. So in this case, we only have one digit that's repeating, so it's all over 9. And then simplify 6 9s if possible. So as we all know, 6 and 9 are both divisible by 3. Therefore, we divide both numbers by 3. And 6 divided by 3 is 2. And 9 divided by 3 is 3. So 6/10 with a bar on top of 6 is equivalent to 2/3 in fractions. Okay? Now to check, did I get the right equivalent? So you can use the calculator to check. So we have a calculator there. You're going to press your answer, 2/3. You should be arriving at 6/10 with a bar on top of 6 or 0.666 and so on and so forth. So 2 divided by 3 is, there you have it. As you can see on the screen, it's 0.666 and so on and so forth. Okay? So let's move on to the next one. Okay. So the fourth one is 2 and 24 hundredths with a bar on top of 24. So this means 2 and 4 on the decimal part are both repeating. Okay? So if that's the case, we are going to set that 2 aside, the whole number, and then we work on the 24 hundredths that's repeating. Okay? So we put the equal sign there. Okay, and then we have 2 and point something. So since 24 or 2 and 4 are repeating, then our numerator will be 24. And the denominator will be 99 since there are 2 digits that are repeating. Now 24 and 99 are both divisible by 3. So we divide the numerator and denominator by 3. 24 divided by 3 is 8. And 99 divided by 3 is 33. So we have 2 and, sorry, I'm going to remove this one. Okay. So we now have 2 and 8 over 33. But this is a mixed number, so we change this into an improper fraction. So multiply and then add. 33 times 2 is 66. And then 66 added to 8 is 74. So that will be our numerator and the denominator will be 33. Then we check. So we then bring our calculator out, bring it out, and then we press 74 will be divided by 33. So the one that will appear must be the given, 2.24242424 or 2 and 24 hundredths with a bar on top of 2. And there you have it. Okay? So it means our answer is correct. Okay? So I'll be erasing the writings and then bringing this back, these items. And let's proceed to the next one. So this time we have to convert 1.13 into fractions, but this time only the digit 3 repeats. So this is the other way of writing. It's 1.1333 and so on and so forth. And we have to change it into a fraction. Okay? So how are you going to deal with that? So again, since we have a whole number 1, we just have to write 1 there. And we have to work on the decimal part. So in this case, 13 is the number formed by the digits of the decimal part. So that will be our numerator. But since there is a digit that does not repeat, we are going to subtract 13 by that number. And the denominator will be a number of 9s and a number of zeros. So we have to work on the 9s first. That means how many digits are repeating? There is only 1, that's 3. So there is 1 9. And since there is 1 digit also that does not repeat, then there is a 0. Then the denominator is 19. Then we perform the operations on the numerator. 13 minus 1 is 12. all over 19. Simplify first this one before you attach it to the whole number 1 there. So 12 and 90 are divisible by 2. So we have 6 all over, okay, 45. This is an example of not getting a GCF. As you can see, 6 and 45 are still divisible by a certain number other than 1. So I just work on this. Let's divide this again by 3. So you have 2 over 15. Since 2 and 15 can no longer be divided by a number other than 1, then we just attach that to the whole number 1. And then again, convert it into an improper fraction, multiply, then add. 15 times 1 is 15 plus 2 is 17 all over 15. And let's check again in your calculator. You press 17 divided by 15. Okay, and there you have the given. The given is 1.13333. On the screen is 1.13333. So that means our answer is correct. So we have to put this down. And you have 17/15ths as the equivalent fraction of 1.13333 and so on and so forth. Okay, so I'll erase the writings again and then you just have to return this. Sorry. Okay, and we now have the last one. So the last one is 5.2066666. Okay, so this time around, okay, sorry, this black. We have a whole number 5. We write that one there. Okay, I'm sorry. I will not be having the decimal point. And then we'll be attaching the fraction with that whole number 5. So I'll be working on this decimal part 2066666. So our numerator will be 206. And since only 6 is repeating, we subtract 206 by 20. Again, we subtract it by the number form by the digits that are not repeating. And then the denominator will be how many repeating digits? There's only 1, so there's 19. There are 2 digits that are not repeating, so there are 2 zeros. So we now have 206 minus 20, and this will give us 186. And 186 over 900. Now, we have to think of the GCF of 186 and 900. Okay, so if you haven't, if you can't think of the GCF yet, okay, you may think of the number that you can use to divide this to. Okay, so as you can see, both are ending at 0, 6 and 0, so you'll be thinking of dividing this 2 by 2. Okay, so 186 divided by 2 is 93 all over 900 divided by 2 is 450. So we all know 450 is divisible by 5 and by 5 to 10. Okay, but 93 is just divisible by 3, right? 45 can still be divided by 450 can still be divided by 3. So that means we haven't obtained the GCF. Divide again by 3. So you have 31 over 150. And I think this time around, you can no longer divide 31 and 150 by other number aside from 1. Okay? So we just have to attach that to 5, the whole number 5. So 31 over 150. And then we convert it into improper fraction. So multiply that add. So we have 150 multiplied by 5 is 750 added to 31. That's 781. So we have here 781 all over 150. And to check, we need to have the calculator. 781 divided by 150 is, and there you have it. You have 5.20 and then the 6, the only digit that repeats on the decimal part. Okay? So that means our answer is correct. Okay. So this time, so we have to answer the question, why that when we convert another repeating decimal such as 1/3 as a fraction is that we have a denominator 9. We always have a denominator 9. That's why you have it there. Why 9 as denominator? Okay? Okay. We all know that 1/3 is equivalent to 0.33, right? 0.3 with a bar on top. So first, we have to let or to assign x to be 0.3 with a bar on top. And from this 0.3 with a bar on top, we just have to move the decimal point one place to the right so that we are going to have a whole number in the decimal number equivalent. So moving that is done by multiplying by 10. Take note. As we multiply by 10, we move the decimal point one place to the right. So we multiply this whole equation by 10. We multiply this by 10. And we have 10x equals 3.3 with a bar on top. We then again write x here to be 0.3 with a bar on top. So we now have two equations, 10x equals 3.3 with a bar on top, and x equals 0.3 with a bar on top. Our goal is to get rid of the non-terminating decimal, the 0.333 there. So we subtract the two equations. So subtracting the two equations, 10x minus x will give us 9x. And this one, the 3.3 with a bar on top and 0.3 with a bar on top, when subtracted, na-eliminate na to decimal part. So we now have 3. Then from there, from 9x equals 3, we are going to solve for x. Okay? We divide both sides by 9. And then we canceled out 9 there. So we have x. And on the right side is a fraction, 3/9, that when simplified is 1/3. Okay? And there you have it. So as you can see there, before we have the final answer here, the 1/3 here, is that the denominator is 9. So we divide both sides by 9 here, and that's why 9 for denominator. For converting non-terminating decimal to fractions, wherein the decimal part have the digits which are repeating. And there you have it, 1/3. That's it, and I hope you learned from this. Thank you.